Hello everyone, so today we're going to be looking at the following limit problems. So for all three of these we're going to be going to taking the limit as x goes to infinity, or x goes without bound, as sometimes we can say. I'm going to be looking at a and b here. Let's start off with a, and I'm going to be using the same type of technique for both. So for a, you have the limit as x goes to infinity of 3x to the fourth minus 5x squared plus 11x, all in the numerator, divided by, on the denominator, minus 5x to the fourth plus 9x minus 1. So what we're going to use is this idea here, that if you have the limit as x goes to infinity, when you have a number over x to the r, that's always equal to 0. So the limit as x goes to infinity of 5 over x to the 7th, that equals 0. The limit as x goes to infinity of 10,000 over x to the 0.1, that's equal to 0. Whenever you have a number and you're dividing them by a power of x raised to some positive real number, it's going to go to 0 because the numerator stays as a number and the denominator is just going to grow. It might grow slowly, it might grow really fast. It depends on what the exponent is. And yeah, as x gets large, for example, with x to the 7th, if you have 1,000, you raise it to the 7th power, that would be like 10 to the 3rd raised to the 7th power is like 10 to the 21. So 5 divided by 10 to the 21 is almost nothing. It's like you have 5 pizzas, you're dividing it by 1 billion friends. How much are you going to have for each friend? You're not going to have much. That's kind of like in so many words what we're saying. And the same thing happens with the 10,000 over x to the 0.1. And also, in general, when you have a number over x to the r is positive, but you're going to negative infinity, and r is a positive integer, it's going to be 0 as well. Now, I don't go into the cases where r is not not an integer, like it could be a decimal, whatnot, because that gets into negative arguments for your base, and you can't take radicals of negative numbers. Like you can't take the 10th root of negative 20,000, for example. That's not allowed. So that's why this is just spoken about in positive integers here, in a little arrow here. Let me just highlight that here in there. All right, so let's get down to the actual limit and how this first technique works. So you're going to take your expression, and first of all, you have to be going to infinity, 1, and the other thing is you need to have a rational function, a rational type function here. And what I'm going to do is this. I'm going to begin by dividing both the numerator and denominator by the highest power, which would be x to the 4th. And the highest power is basically the highest power that's would be the highest power for both the numerator and denominator, which would be x to the 4th here. All right, so then I'm going to go ahead and do as follows. I'm going to rewrite this expression as 3x to the 4th over x to the 4th minus 5x squared over x to the 4th plus 11x over x to the 4th, all divided by minus 5x to the 4th over x to the 4th plus 9x over x to the 4th minus 1 over x to the 4th. And when you rewrite that, this would simplify as 3 minus 5 over x squared plus 11 over x cubed minus 5 plus 9 over x cubed minus 1 over x to the 4th. And your limit would come out to be negative 3/5, because all of these other terms that you see go to 0 because they're all numbers divided by x raised to a power. So your answer is minus 3/5. Okay. Now, the other way to do this was more computationally taxing, and I think that's for sure. Then the next method is as follows. So what we're going to do is, that's the next one, is as follows. So or here, so this is the alternative. And the way this works is as such. I'm going to go ahead and take the leading term of the numerator and denominator. For the numerator, that'd be 3x to the 4th. For the denominator, be minus 5x to the 4th. And the limit as x goes to infinity would rely on both of those only, okay? It does not rely on anything else. As x gets really large, 3x to the 4th is the largest out of minus 5x squared and 11x. Now it's not just important that it's the largest, the other two make almost no difference in comparable size to 3x to the fourth. 3x to the fourth just dominates everything. And likewise, minus 5x to the fourth just dominates everything there. Okay. Now, what we're going to do next is say this, that with my, let me repeat what I have with my equation, is that, yeah, the leading terms are what determines the limit for a rational function. And what happens here is that the powers cancel each other out, and you just get minus 3/5. So you simplify your expression to something a lot easier. There's pros and cons to both methods. The first, I think, is more computational in a sense. The con here for the one we just did here is that, yeah, you have to look at the leading terms, what they are, etc., and go from there. And that's not always easy depending on the function, okay? And for the pros for the first one is like all the work is, as much as you do a lot of it, it's there, it's in steps. And yeah, there is no work for this other method as well. Sorry, not as well, just there's no work here. Anyways, so you get that, and then I'm gonna, this is B, limit as x goes to negative infinity of 3x cubed minus 11x to the fifth divided by 27th x to the fourth plus 3x squared minus 1. This limit, by using that second option, which was looking at the leading terms, would look something like this. Those are the leading terms for the numerator and denominator. It's just the highest power with the number that's on top. And simplifying that, this is what you'd get. Well, as x gets really large, it goes to negative infinity. This would go to infinity, okay? Because x gets really large, then negative 11 times, well, technically as x gets really small because you're going in the other direction, negative infinity. So you have negative 11 times some huge negative number. It's going to become a positive number that's huge. I'll divide that by 27, that's infinity, okay? So, and then, yeah, you can do this the first method as well, and you would get the same exact answer. All right, well, thank you so much for watching this video. I hope this helps. And for the next video, we'll tackle on part C.